Hello guys, and welcome to a new week. So this is week 2 of distance learning, which means it is day 4. So for A day, you're watching this on Tuesday, April 7th, and B day, you're watching this on Wednesday, April 8th. So the last 3 videos that I've posted with 3 quiz practice has been review, but now we are getting started in a brand new unit. So the unit that we're going to be looking at would have been Unit 6 at school. It's the fundamentals of linear equations. And I'm going to keep posting the skill right here so that if you need to look up another video, in case this one doesn't help you out, or if you need to look up some extra notes, you can always search the skill right here. So finding slope from a graph is going to be what we're looking at today. And also I'm going to introduce you to what slope is in general because we haven't talked about that yet at school. So we're going to, again, we have joke of the week, we got the date, it's day 4, we got a new coordinate plane up here, so we're going to dive right into what slope is. So I have just sketched an image of what I'm going to call a mountain range, and it kind of is changing. So from the very beginning it's rising and then it's falling, so it's decreasing, and again it's rising again, but not quite as high, and it's not as steep. So what we're going to be talking about with slope is how steep a line is. So if I take a look at this first peak of this mountain, this first peak, this rise, is much steeper than the second peak. So the difference in that steepness is what the slope is. So we're going to be comparing the types of slope today, and then we're actually going to be finding the slope of lines on a coordinate plane. So if I give you a graph, can you find the distance, or the difference between the y values and the x values? So there are 4 different types of slope. So we're going to take a look at slope in terms of money because I know we love looking at it like this. So our x-axis for all 4 of these graphs is time. So as time goes on, what's happening? So we have time across our x-axis, and our y-axis is looking at how much money we have. So that's what this little dollar sign means. So as time goes on, how much money do we have in the bank? So there are 4 different ways to describe this. The first is if you start with very little money, and as time goes on, it's increasing, so your money, your y values are getting bigger. As time goes on, your line looks like this, almost like running up a hill. And we're always going to read graphs like we read in English. We always read in order from left to right. So if I look at the beginning of this graph, it's way down here, and by the end, it's way up here. And it's gradually and consistently changing in a positive direction. So this first graph represents a positive slope. If I take a look at this second graph, I start with a lot of money, but my money is decreasing at a constant rate. So in this case, this blue line is representing a negative slope. It's decreasing as time goes on. Then we can have some money to start with, and if you notice, our money is not changing. If you remember that distance activity that we did in class with the gizmo where we got to walk around the classroom, this is like somebody not moving, right? Their distance isn't changing. In this case, our money is not moving. So the slope of a line that looks like this, a horizontal line, is 0. And then lastly, I know we've talked about the vertical line test when we were testing if graphs of functions or graphs were functions or not. This vertical line right here, it's like saying that at this time you had no money, but then you had all the different amounts of money, which doesn't exist. So this vertical line is called an undefined slope. And that's another reason you can't be in 2 places at once. You can't have the same amount of money at once. You can't be the same 2 different ages at once. So in this case, this slope is called undefined. And it's not even a function. So a vertical line represents something that's not even a function. So those are the 4 different types of slopes. If you need to hit pause to write down those 4 examples, you can. I am going to be posting slope notes. So this is what we would have done in class anyway. I have filled in the blanks for you using red. So again, what we've gone over so far, the steepness of a line is just called the slope. Slope is the ratio of the vertical change to its horizontal change. So we're going to talk about that in a second. And then we can also refer to slope as the rise, that vertical change, over the run. So the way we're going to compare slopes, compare steepness, is how fast something is changing on the y-axis versus how long it takes to get there on the x-axis. So if I give you a graph, and so you have a graph over here, you need to first find what I'm going to call good points. And good points always meet at a coordinate that I can figure out what the coordinate is. In other words, it's right where my grid in the background has a corner. So I can see exactly where these points exist on my graph. So to find the slope, I'm going to compare this to my types of slope. So if I'm looking at this graph and I'm reading it in order from left to right, it's heading in the positive direction. So at the very end of this, when I find the slope of this graph, it should be a positive number. So I need to start out by finding two good points, and it does not matter. We have lots of points on here. In fact, there's infinite many number of good points. But from the ones that I can see, I'm going to use this one right here and this one. And I'm going to pick the two closest together because that's going to save me from having to simplify a fraction, though there is nothing wrong with choosing two other points on this graph. So what we're going to do now is calculate the vertical change, right? How fast it's changing vertically. I'm always going to start with the point on the left, which would be this one, and I'm going to count how many boxes it takes to get to that second point. So my rise here, see those 3 loops? My rise here was going up by 3 units. My run would be from here to here. That would be running across 2 units. So my vertical change was 3. My horizontal change was 2. So again, if I'm going to be calculating that slope, it's going to be the rise over the run. And my vertical change there was 3. My horizontal change was 2. And I don't need to convert that to a mixed number. We're going to leave slope as an improper fraction because I want it to be the ratio of the rise to the run. And 3 over 2 can't be simplified. And it is a positive number, right? Because we don't have any symbol in front of it. So the slope of this graph right here is positive 3 over 2. That would have worked out in the same way if you had chosen 2 other points. If you had chosen these 2 further points, we would have counted our vertical change. So again, 1, 2, 3, 4, 5, 6. And our horizontal change would be 1, 2, 3, 4. So this time my rise was 6 units, my run was 4. But because we're mathematicians and we can simplify our fraction, I can divide both the top and the bottom, both the numerator and the denominator, by a common factor of 2 to get the slope of 3 over 2. So no matter where you check the vertical change against the horizontal change, it's always going to simplify to 3 over 2 for this line because a linear function has a consistent rate of change. We're going to take a look at one more graph. So here is a brand new graph, and if you notice, it is not as steep as the original graph. The original graph was looking more like this. So now this purple line, I could tell it's still heading in a positive direction, but we know that the slope should be smaller than 3 over 2. So we're going to check this out by, again, finding 2 good points on this graph. I'm going to use this, and then I'm going to count my rise, which happens to be 1 unit here. So my rise was 1. My run is 1, 2, 3. So the slope of this line is 1 over 3, which is in fact smaller than 3 over 2. So we still have a positive line. It's heading in a positive direction. My rise was 1. My run was 3. So the slope of this line, which we can use m to represent the slope, would be 1 over 3. Okay? We're going to look at just one more example. Because I know this is a new topic. I am going to be posting another introduction video where somebody's actually using their computer to describe this, which would be much easier than what I'm doing by hand. But it would be good to take a look at a few examples. So we're going to do one more graph. Let's put a point here. So here is one more graph that we're going to take a look at. And I can see a difference in this graph. Instead of heading up from left to right, it's actually heading down. So whatever happens at the end of this, this should be representing a negative slope at the very end. So when I'm taking a look at here, I have 2 points that I can use. We can use this and this, right? And again, I know every box on this grid here is a 1 unless it's otherwise noted. I can take a look at my change in y. In this case, we're heading this way. I didn't go up, I went down. So I have to represent that by using a -2. So my change in y, or my rise, is actually going down 2 units. And my run, 1, 2, 3, 4, is going across 4. So my slope is a negative, which makes sense. It's heading in the negative direction. It's decreasing as time's going on. But -2 over 4 can simplify to -1 over 2. So the slope of this line is -1/2, or -1 over 2. We are going to continue with practicing our slope. On that notes page that I told you about, it has 3 examples already done for you, using the same counting of the rise over the run. And at the very bottom, if you'd like to add in some notes for yourself about how you would find the slope from a graph, I would do that. So I'm going to post a few more things than normal. So in your Google Classroom, I'm going to put a link to this video, which if you found, good. I'm going to put the link to your quizzes with the code that you need for today. But then I'm also going to be giving you the link to this note sheet, which you could print out or write on a separate sheet of paper. And I'm going to be giving you a link to another video to help you get familiar with what slope is and how it works and how to specifically find the slope from a graph. Okay, so we are going to continue with slope, talking about slope on Thursday and Friday this week. I hope this was okay. Please give me or send me an email if you have any other questions. Otherwise, I'm going to try to set up a Zoom chat this week so that we can get together and talk about the new stuff that we're learning. All right, I hope you all are doing well. I really do miss you, and I wish we were back in class.